Hello everyone. So today we are going to see problem number 869, reorder power of 2. So before that I would recommend you to watch my previous video power of 2. In that I've explained what exactly power of 2 is. Okay. So let's get started with this problem. You are given an integer n. We reorder the digit in any order including the original order such that the leading digit is not 0. Return true if and only if we can do this so that the resulting number is a power of 2. So we are given an n and we can rearrange its digits. So like here we are given 10, right? So we can make it 0, 1 also. But in that there is a condition that leading number should not be a 0. So we cannot do that. And we have to find and check if that is a order of 2 or not. So for a number to be order of 2, it should only have one bit set in the binary representation. And so we need to find such numbers who have only one bit set. So let's write a bits, okay, from 1 to 4, 8, 16, 32, 64. Okay, so these are the bits in the binary representation that we are using. Okay, so this all 32 bits, okay, as we are dealing with the integer, all 32 bits will be a power of 2. Other than this, there will be no power of 2. Like if we consider 6, okay, we will represent 6 like this. And 6 have 2 bit set. I told you for a power of 2 there should be only one bit set. So this is not a power of 2. Okay, because we cannot represent it 2 raised to something equal to 6. We cannot do that. Okay, but we can do like 8 equal to 2 raised to 3. Correct. Okay, so this is one observation we have. Let's see how can we solve this problem and think about it. So initially let's take a number 1 812. Okay, 812. Okay, we took it. We'll write all. We can do one thing. We can make all the permutations. Okay, so we'll write 812 itself. 8112 itself. Okay, then comes 821. Okay, then we'll start the permutations with 128. Okay, then we will go 182. Then we'll go starting with 218 and 281. So these are all the possible permutations for 812. Okay, then we can make this one and check if it's have only one set bit. That we can do by Kagnan's algorithm that I've taught in my previous video. Okay, but this will be a very lengthy process, I guess, like to make all the permutations, as we have given the constant as 10 raised to 9. So it will be having 10 digits, and for 10 then okay, that is also possible, but we can find something more efficient. Okay, so what my observation from this is, suppose we take again that number 812. Okay, and we see the binary bits. Okay, 1 2 4 8 and so on. So we have only 32 numbers to compare. Why should I make all the combination permutations of this one? I only have 32 bits, correct? So I will just compare this number frequency with the 32 bits and check it if I am able to reproduce the one of the 32 bit number from this n by rearranging its digit, correct? That I can also do, right? So we'll be taking that approach only, and we'll see just one iteration and for this. So we'll take again the same number 812. Okay, and for this number I will make a frequency array. So maximum digits we have is 0 to 10, 0 to 9, sorry, not 10. So 0 1 2 3 4 5 6 7 8 9. Okay, we'll be having this. We're not going to write 10 because it's digit only, we have 9. Okay, so we will make a frequency array for this. This will be 1, this will be 1, and this will be 1. Okay, and we will travel from 1 to all the 32 bits. Okay, and for each bit we'll making a frequency array and comparing with the frequency array of n, this n. Okay, so here if I make for 1, initially it will be 1 only and it's not matching. When we iterate it and when we compare, when we come at index 2, it will be here, it will be 1 and here it will be 0, so it will be not matching and will returning a false at that time. The next iteration 4, so 4 we are only getting 1 bits. Okay, so again we will be returning false. Then comes 8, 16, so then comes one number 128. Okay, so for this 128 we will be having this one, this one, this one. So frequency matches here and we will be returning true. So in this way we can write the code and hope you get the implementation through this iteration. So now you can pause the video and try to write a code by yourself, or after you have tried you can follow the video and I will write the code now. Okay, so let's take a frequency array first. Req, okay, equal to new int 10, because we have 0 to 9, correct? Okay, then after that we'll make a frequency for n. So how will be, while n is not equal to 0, okay, frequency of n by 10 is, we're doing it plus plus, okay, and n equal to 10, equal to 10, and we'll be dividing 10 by this will give me a frequency array. Okay, just then after this we'll be iterating for int I equal to 1, I should be less than 32 I plus plus, I plus plus. Okay, in this we get all the bits. We'll just write a function, okay, so that it makes it, because we have to calculate many times the frequency. Okay, so and compare it, so we'll public boolean compare. So in this we having a frequency array q comma int n. So we'll be comparing both. So first we'll make current frequency. For this I will not write it n, we'll write it as bit, okay, for better understanding, equal to new 10. Okay, we'll just copy this code from here. Okay, while bit is not equal to 0, instead of frequency we'll replace this bit by 10 and bit. So this will create a frequency array for bit also. So every time we are iterating we are calculating the frequency array and then we are comparing it. For 90 I equal to 0, I should be less than 10 I plus plus. If FREQ of I, sorry, FREQ of I is not equal to current FREQ of I, then we will return false, and if it matches we will return true. So this function is clear what it is doing. It will take the frequency array of our n and give us a bit, then we are creating a frequency array for our bit and then we are comparing both the frequency array. Just we are doing like this. Now we will be iterating. If, okay, we will be calculating boolean, okay, sorry, boolean answer equal to, we'll be calling this function compare. Okay, we'll passing frequency in this comma 1 left shift I. Okay, we'll be starting to 0 for this. Okay, 1 left shift I, and if answer is, if answer is true, we'll be return answer, we'll be returning true, that is. And here if we don't get an answer we will return false. So our code is done. Okay, let's try running it. Okay, something. Oh, I think I forgot to write int. Array index out of bound. Okay. Why is it so? Why is it so? So I got the issue. So we have written here 32, right? So we need to make it 31. Other it will go to the minus side of the binary representation. And now we'll try running it. Okay, it's working fine. I'll try to submit it and let's see. Yeah, we are done now. So here the time complexity for calculating the frequency array means making the frequency array will be n only, and for comparing also we are doing n work only, so it will be big of n only, and space complexity will be big of n because we are using two frequency array, but it will be counted as big of n only. So thank you for watching the video, hope you get it. If you have any doubt, please comment down, I will help you to clear the doubts, and please subscribe the video and press